All right, let's talk about AI. It's everywhere, right? It's making these huge decisions that shape our world, our lives every single day. But as these algorithms get more and more powerful, you got to stop and ask, what's their moral guide? What's their compass? That's what we're digging into today. So let's just start with the big question right up front. Can a piece of code, just a bunch of ones and zeros, actually be unfair? The answer is, oh, absolutely. And figuring out how that happens, well, that's the key to this whole conversation. To really get to the bottom of AI ethics, first, we've got to pop the hood and see how these things are actually put together. So let's take a quick look at how an AI project goes from just a tiny little idea to a full-blown product out in the world. Okay, forget AI for a second. Let's make this super simple. Imagine you're just making a birthday card for a friend. You brainstorm some ideas, you figure out what you need, paper, glitter, you know the drill. You gather it all up, you start making it, you fix that little smudge, and then you give it to them. It's a simple, logical process, right? That's a project cycle. Well, believe it or not, that exact same logic is how we build AI. It's called the AI project cycle. You scope out the problem, you get the data, you poke around in that data, you build the model, you test it to see if it works, and then you send it out into the world. Now, here's the kicker. Every single one of those steps is a point where our own human blind spots, our own biases, can creep. Now, you should know that AI isn't just one giant monolithic thing. Not at all. It's more like, I don't know, a toolkit. It comes in a few different flavors, and the flavor you get depends entirely on the ingredients, the data that you feed it. Let's look at the three big ones. First up, we've got the number crunchers. This is AI that lives and breathes statistical data. We're talking spreadsheets, tables, categories, all that good stuff. These systems are designed to just tear through massive amounts of data to find patterns nobody else can see. And you've seen this stuff everywhere, probably without even realizing it. Those price comparison websites that help you find the best deal, that's it. The crazy complex systems trying to predict the stock market, yep, that too. Even the programs that make sure your local store has what you need in stock. It's all powered by this kind of AI. Okay, next up is computer vision, or CV. And this is pretty much exactly what it sounds like. It is the science of teaching machines how to see. It's all about feeding a computer tons of images and videos until it can actually understand what it's looking at. And the applications for this are just wild. Computer vision is used by farmers to check on crops from way up in the sky. It's the engine behind facial recognition systems. And of course, it's the eyes that let a self-driving car tell the difference between a stop sign and a tree. And our third flavor is natural language processing, NLP for short. This is the magic that lets computers understand us. It's the bridge that allows a machine to interpret and even speak back in our own messy, complicated human language. You use this all day long. Seriously, the spam filter that protects your inbox, that's NLP. When you use Google Translate to figure out a menu on vacation, NLP. And when you ask Siri or Alexa for the weather, you are literally having a conversation with an NLP model. So we have these amazing tools, right? They can understand numbers, see the world, and even talk to us. But this is where the trouble starts. Because hidden inside all that brilliant programming, our own human flaws can get baked right in. We're talking about bias, a ghost in the machine. Let me ask you something. Quick thought experiment. Somebody hands you $100 and says, donate this to a good cause. You have a few options in front of you. How do you decide? What's running through your mind as you try to pick one? Your choice probably wasn't purely logical, was it? Maybe it was influenced by your culture, your personal values, or who was located closest to you. We all have these internal shortcuts, these biases. And here's the danger. If we're not incredibly careful, we build those exact same biases directly into the AI we create. So if bias is the poison, what's the antidote? We can't just hope for the best. We need a tool, a guide to help us navigate these really murky ethical waters. We need to forge an ethical compass for ourselves. And that compass has a name. It's called an ethical framework. Now, don't let the fancy terms scare you. Think of it as a checklist for morality. It's a structured process that forces us to stop at each stage of building an AI and ask a really simple question. Could this decision I'm making right now cause harm? And these frameworks tend to come in two main styles. You've got your sector-based ones, which are custom-made for a specific industry, like bioethics in healthcare. And then you have value-based frameworks, which are built around broader moral ideas, like protecting human rights or doing the greatest good for the most people. Theory is one thing, but let's make this real. We're going to walk through a case study from healthcare and see how applying one of these frameworks, bioethics, could have completely prevented a disastrous and deeply unfair outcome. Okay, so here's the scenario. A company built an AI with a really noble goal: find the highest risk patients so we can give them extra care. But the result was a catastrophe. The AI started recommending less care for some of the sickest patients. How in the world could that possibly happen? Let's apply that bioethics framework and see where things went wrong. Principle number 1 is respect for autonomy. This means transparency, no black boxes. If this framework had been used, patients would have the right to know exactly how the AI was making decisions and what data it was using to do it. That brings us to the second, and maybe the most famous principle of all: do no harm. The AI failed this test spectacularly. And here's why. It wasn't trained on how sick people actually were. It was trained on healthcare costs. And because, historically, less money had been spent on patients from one particular group, the AI learned a terrible, flawed lesson. It decided that lower cost meant better health. This would have actively denied care to the people who needed it the most. Which leads right into the third principle. See, building ethical AI isn't just about avoiding bad outcomes. It's about actively trying to do good. The principle of maximum benefit would have forced the creators to ask a much better question. Not, how can we use this cost data, but how can we find a data set that actually reflects the true health needs of all patients fairly? And finally, we land on justice. An AI doesn't exist in a bubble. It operates out here in the real world with all of our existing inequalities. A just AI has to be designed with that in mind. It needs to be aware of the societal biases baked into our data, and it has to actively work to counteract them, to make sure its benefits are distributed fairly to everyone. Just by applying that simple 4-step framework, the creators could have caught this fatal flaw before it ever hurt a single person. Which really leaves us with a final, giant question to chew on. When an AI makes a mistake like this, who is truly responsible? The programmer, the company, the data itself? That's